Forgot. Okay. You want to share the whiteboard? You want to share your textbook or
Could we share the whiteboard?
okay. Wait, give me a moment. I just prepare some dark background. When will be your exam? Next week?
It's not next week.
Not next week.
It's the week after, I think.
Oh, one more week. Okay. Okay, you can write any question you want to discuss. Body of mass 2G is initially kinematics or not?
This is math.
AD. Two. Okay. Force, yes. Yeah, it's kinematics. It's a motion, acceleration. One acceleration, the body moves in the straight line path. Okay. Right. So what is the condition given the mass, right? The mass is given. M, is this 2 or 20?
2 kg.
2 kg, okay, 2 kilogram. Initially at the rest, okay. So what does it mean at the rest?
Initial velocity is 0.
Yeah, that's u equal to 0, yeah. Anything else? We can try. Only by the resultant force F, what does it mean? 0. Newton, right?
No, that's V minus 4.
V minus 4. V minus 4, right? That is force. That is force. Okay. You can set up equation to solve this one. I think it's very straightforward if you Newton's law.
I'm not sure how to start here.
Well, you are right. You can write Newton's law. The force, resultant force, is equal to the product of mass and acceleration. So if this acceleration is to be discovered, to be determined, then you only need to work out what is the force. The force you told you, force can be written as this formula, which is V take 4. Is that right? There's 2 equations here. Actually, 1 now. Can we set up equation? That's right. Wait a moment. You have divided by the mass, right? Oh, you divide by 2. Oh, that is number. You use number 2. Okay, fine. So that is the first equation, right? So what can you do? What is the relation between velocity and acceleration? Correct. Okay.
Yeah.
So yeah, that's right. So in this way, you found the acceleration. Do we
Mhm.
have to work out the other things? Find the acceleration. What is the question?
No, and then question B.
Oh, no. Wait a moment. Is that question A now?
Yeah.
Okay. All right. Okay. Solve a differential equation. Okay. You found the velocity. Is that right?
Mhm.
Good. Okay. Yes, this is a simple differential equation.
Yeah.
Can you try?
Um,
Oh, yes, that's right. Oh, good. Oh, that's quick. Good. Can we write it a different, can you solve the formula for V? Oh, you determine the constant first. Fine. Oh, wait a moment. Can log equal to negative or not?
no.
Velocity, the velocity is not zero. The constant is zero. The time is zero. The time is okay, but this is not zero. Is this zero or not?
It is because it's initially
At the
rest.
rest, initially at the rest. Okay. Oh, that is the point. Yeah, that's what I'm thinking. Why don't you, because this negative seem a little bit odd. Can we just start from here to rewrite this into the exponential form? You want to try? So how do we write? Oh, this is absolute value. Did you use absolute value?
Yes.
Okay, that's right. All right, it's all right. Yeah, I think if I were you, I would just start to write an exponential form before I determine its constant. Okay, it's up to you. It's fine.
Mhm.
Okay, next one. This question one, yes. Question one. Can I go to next page or go to next page?
Yes.
Okay, next page. complex number is tangent to a curve. Oh, wow. Tangent. Find the
Value of k.
value of k. Okay, k is constant, k is unknown, right?
Mhm.
Okay, so this is a k over here. Can we just can you draw the diagram to indicate that the position is point? This is k, right?
Mhm.
Is this k as well? No,
Yes.
2k. Now a k appear in the two position.
Mhm.
So k is the real value? Real value, of course, right?
Mhm.
Okay,
It's greater than 0.
greater than 0.
Oh, less than 0. Sorry, less than 0.
It's negative. K is
Mhm.
negative. Wow. It's a tangent to the curve, so we don't know the curve. What does it? You have to ask, what does the curve looks like? What do you think?
This is the curve.
Yeah, so the shape, I know there's a formula, but what does the shape looks like? Can you try to work out this curve? That's right. It could be just a circle, isn't it?
Mhm. Mhm.
Yeah, it could be parabola. I think it's quadratic. X, Y. Cancel X, Y. 6. Yeah, good. Yes, I think it's a circle, right? But the
Mhm.
center is not at the origin. Okay. Is this full? Are all this
Mhm.
full? Is it
Yeah.
full? Okay. Okay. Good. Yep. So that is clear now.
Mhm.
We know this. Can you draw the diagram? Can you draw this circle in the complex plane? Where is the center? Where is the center of the circle?
At -2.
Negative 2i, right?
Mhm.
This is imaginary, this is real.
Oh, right. Mm.
Make sure it's the proper scale. Can you see? If this is 2, so this 2 must be here. Can you see? 2 will be here. Yeah, these are equal, okay? These are equal. That's right. Yeah. You can have there's a toolbox. You can use you can draw a perfect circle here. Yeah. Okay. That's it. So that's a circle. Now, where is the point? Can we look for the point? They must be on the circle, right?
Yeah.
That is also the tangent at that position.
So we have to first do the tangent.
Well, where is that point? This is K. We don't know the K. To the curve given by. So it must be a tangent. They only give you the point. They should have 2 tangents, right? If you give the point in a complex number, right? They should have 2 tangents in principle. You agree?
Yes.
So is that the question? So these have 1. They have another one. You see?
And these points are on the same.
Oh, the 2 points. Oh, these are correspond to 2 points. This is they got the 2. Oh, this time they give you 2, 9. Can you see? Okay, so they give you 2, 9 in the complex number, right? Which is also tangent to that one. All right, they imply the function that this if you combine them, and they should have the quadratic equation. Do you agree? They satisfy the quadratic equation. So this is I don't know which one. So this point is 1. So that must be so at this particular point, and x and y will satisfy a quadratic equation. But how can we find them out?
I don't know.
The complex number have these two 9 is certainly on the straight line, right? And I think what you can do is convert it. Perhaps we can convert it into the real number problem. Do you agree? Because we don't have to consider this. That's my idea. Can we just redraw this one in we don't have to redraw that. So basically we have to consider this as 2 point here. Can we just draw the real? Can we just draw a real complex coordinate, right? Because after all, we are trying to work out that k, that is the imaginary part, that x, can you see? So let's just do this one. So we know there's a circle here. We know there's a circle down there. And we know this coordinate, this is a -2. Can you see? I use y now, can you see? I use a real number. I just forget about that there's a complex plane. So basically this is 0. So the first one will be k, -2, right? So k must be along this in this straight line. K must be. Can we draw another straight line? This is y equal to -2, right? And -2. Another is negative. That is another is x equal to 0. That's a real number, right? X equal to 0. Can we see that? This if k is negative, right?
Yeah.
Okay. Can I just call this k? All right, we just call this k. We will see if that we just arbitrarily just choose this k here. Okay. So there's 1 point. Another point is at x equal to 0, y equal to 2 minus k. K is negative, right? K is negative. So k is larger than -2. Are you sure k is negative? It's very strange. Did they say k is negative?
Yeah.
That's interesting. So basically, we know that this another point is in the y on the y-axis. Okay, if so, somewhere here, because there's another point here. Okay. However, if you choose this one, that doesn't give us a tangent. Can you see?
Yeah.
So what we can do is that we have the this is just trial. This is not this is not necessarily the straight line, okay? Because this straight line is certainly not a tangent, okay? But before that, we need to build equation for this one. Can you try? Can we work out the slope and the x-intercept based on these 2 points? You see? Can you try? So what is this straight line? Can you work out this the function of y? In term of k. So to be exact, this is a negative 2 plus k, right? Or we don't have to consider k, okay? We just take a k as a k, all right? If k is negative, it's negative. If k is positive, it's negative. Do I have to consider? Do I have to treat this k as negative? Up to you. Up to you. Yeah, so I'm a little bit concerned about this notion, but that doesn't matter. You can try. If we have trouble, we go back. All right. I wouldn't treat that k as put additional negative sign here, but you can try. All right. And so once we got this equation, what can we do? We got 2 equations. They are tangent to each other. So what can we do now? We got 2 equations. If that is a tangent, then they should have just one intercept. Do you agree?
Yeah.
Okay, so can we just equalize these 2? Do you know what I'm going to do now? We just equalize this x squared plus y, or we just return to the original. It doesn't matter. You can, let's give us some idea already. So these 2 minus r, oh, we have to solve the y. We have to solve the y. Can we solve the y in this equation? What is the y? Basically, we have used criteria to discriminate for the single solution of the quadratic equation. Good, good. So we have equalized them. Do you agree? Do you agree? So we got this y. So we'll probably use this space here. That will be enough. We use this space here. So these 2 must be equal, right? So this root, if you wish, you have positive, negative. We will see. Yeah, normally you have put negative, positive here. that is minus 2 is equal to other side, can you see, of your equation, can you see? Can we just call this alpha and beta to simplify this question, all right? Or A and B, or rather just call A and B, okay? This must equal to X. We know that A can be written in terms of K, right? X plus B plus A plus B, all right? So next, what can we do? We can build the quadratic equation. Can you try? This is positive, this is minus plus. Better put that sign here. Okay, go on. Oh. No. Ah, you use a freshman streams. It's a freshman stream. No, you can't. You have to first prepare this. Can you say to that? If 4 take x squared, yeah, that just equal to ax plus b plus 2. Can you see? And then you square both sides. Then you square both sides. You see?
Yeah.
Yeah, it's very, very tedious because you have. Well, that is a specialist question, right? Yes. Can you go further? It's quadratic, isn't it? It's just quadratic.
Yeah.
Okay. So what you do, we can stop here. Basically, what you can do, you can just prepare this as alpha x squared plus beta x plus gamma equal to 0. Can you see that? And then you ask that the discriminant, right? Do you remember? That is a beta square. Do you remember this one? You just net equal to 0, okay? From this one, you should solve the k, okay?
Yeah.
Do you know the direction to go now?
Do you think we could attempt solving for k just to see?
Oh, you want to, if you wish to solve that, that's fine. If you want to show, yeah, I can prepare some spare. Can we just save that? Be sure. Yeah, you can continue. Yes, please. You can. Can you use this? Can you solve this one? Basically, you have to make sure what does that mean. Oh, did you use different color? Well, I can't see. Okay, I can see it now. Oh, I forgot to tell you. You could use another notation to put them. Oh, you have done it. Doesn't matter. If I were you, I would just put another letter to represent the b plus 2. Anyway. Then you have arranged everything in the form of the quadratic equation. Yeah, we got a 3 coefficient. Equal to 0, right?
Mm-hmm.
Good. Wow, you got this ABC. Oh, you have to solve them. You can't solve that way. You have to simplify this by expanding them and put the similar term together. If you use a square root, then you cannot simplify further.
Mm-hmm.
Where is the K? K is in both A and B, right?
Yeah.
Wow, have fun. Can we stop here? It's unnecessary. Okay. This method is important, but we have to go back to see if any other alternative. Given the complex number, do we have taken advantage of complex number to solve this? Are you familiar with the graph of the complex number? Or we have to go to the next one. I think this question could be oh, well, probably another alternative, because if they're talking about tangent, right?
Mm-hmm.
If they talk about tangent, then we have to, there's not many choice, but use this quadratic discriminate, can you see?
Mm-hmm.
We stop here, is no point, okay? Very complicated formula, I can tell you. I will let you know next time if we can have other simple way, okay?
Yeah.
And can we go to another question now? It's trigonometry or complex number. The position is modeled by this sign. Oh, it's just a trigonometry model or not?
Mm-hmm.
It's IJ is vector, right?
Yeah.
IJ is vector. So time is between 0 and this number 0.15. Find the acceleration. Oh, I see. Position vector. Oh, this is very simple. This is same to the first question. You can try. I think you should be able to solve this one. Perpendicular to the velocity. Okay, sure. So you have done first derivative, right?
Mm-hmm.
Mm. Yeah, that's a unit vector ing. I thought it's complex number, it's not. So velocity is vector.
Mm-hmm.
This is a unit vector. Also the unit vector.
How do we show that it's perpendicular?
Yeah, that is, as I'm wondering, this is a circular motion or not? The circular motion? Let's double check that, 1.3. Can we double check that? Can we rewrite this position vector first? I think you are dealing with circular motion. Can you rewrite the condition given, right? That is, this is a number. Is this number? Yeah, it's not a huge number here. Can we just call this is we know R no, sorry, R no. Okay, so it's R. It's constant, right?
Mm-hmm.
That is as can be written as a sine. I denote all this as theta. Plus this is I, this is I, and then all of that. Yeah, this is the same. Yeah, this pi is the same. So can we just simplify this as this is our is actually they are doing the I just explained to you they are actually doing the circular motion, right?
Mm-hmm.
So when you do a circular motion, the acceleration is perpendicular to the center, to the velocity. So basically let me draw this diagram for you. Yeah, we're dealing with a circular motion. And one moment. Circle. So basically what this position vector tell us is that we can choose the R here, can you see?
Mm-hmm.
So this is, we can just, sometimes you need to, the graph will help you. So this X and Y. And in this case, this is R, so this is our R vector. And the velocity should be, so this R vector. The velocity should be, because you have to be careful, this is our theta, so this is our theta. So obviously this particle is doing circular motion. And the acceleration here, the velocity, can we just do the velocity vector? The velocity vector should go that direction. See, it's tangent
Mm-hmm.
that direction. And we know that acceleration should be perpendicular to this one. Or not, yes, in this case, because oscillation, right? This acceleration. However, if you just do the second derivative as you did, this is not a straight line function problem. Can you see? These formula, the method you used here, you can apply to the oh, so I think we're still in general, you can. Find the acceleration of object, and that its acceleration is perpendicular to the velocity. That's very amazing, because the if the circular motion, the acceleration, I can write a formula here. Can you see? As acceleration is called centripetal acceleration in physics. Do you remember? Do you remember the centripetal acceleration formula here? That is a velocity square divided by r. Can you see?
Yeah.
So from here to here, I don't think you can do that, because this from here to here, I doubt you can. I put a question mark here. All right. I think we have to use this formula instead. It's called centripetal acceleration. You know what I mean?
Yeah.
Centripetal acceleration, which is a perpendicular to velocity, by the way, right? So I don't think this is a, if you just simply do first derivative, if you do, well, I think it's still okay. Because that is something interesting. You got a cosine, sine, cosine. Yes, I think you still can use this method, all right, without considering this formula here. Is there's a guarantee that the direction is toward the center? I think so. Because that return. Oh yes, that's right. That you are right. So that you don't have use this formula in this case. All right. Because what happens is that once you do the first derivative of the that, and that after do that you have became, this is r is constant, right? It's just this become cosine theta, that become r negative sine. Can you see? Ij. Yes. So after you do the second derivative, I don't have to write this twice. That's become acceleration, as you have done. In this case, A will parallel to R again. Can you see? And actually opposite direction. Can you see that? Oh, okay. Can you rewrite this result phasor? Can you see? So this result, can we put can we put this any constant here? So that is that's 1.3 pi squared, right?
Yeah.
And inside it's just negative r. Okay, I don't want to go further. Can you see that? So your formula automatically shows that the acceleration is indeed toward the center. You see, because A is equal to a constant multiply r. Can you see that?
Yeah.
And you see this is r sine, this one cosine is exactly the same of these two. Can you see? Sine and cosine. Yes, you do not use this one, okay? Because that the general formula automatically give you the direction of acceleration. Okay, so don't pay attention to this one. Okay, it's automatically done. Can you see? So this y is perpendicular to the because that eventually you got this formula. Can you see? You got the constant multiply r. That's y is toward the center. So you have one more step. Okay, you need one more step to get this form. So you know the acceleration is indeed toward the center, okay? This is y, this is x. Yeah. No more question? Any question? Next page.
Then part B.
Yeah. Sometime I give you a suggestion. When you see these numbers, all right, to simplify, please use this. Can we go? Can give me a moment? Can you just use this notation to simplify this? All right. There's no point. You see, you see. Look, you are a very careful person, but there's no point to take it because the chance, the probability is high to make some tiny mistake. All right. So what do? You please just use this letters to represent this. You know, this is just strange numbers, right? I call it silly numbers. That's just one suggestion, all right? That's how we're dealing with physics. We don't pay much attention to number. We just substitute number at the end. Okay, go on. Find the speed in kilometer per hour. This is a physics question, right?
Yeah.
Okay, go on. So what is the speed?
Speed is velocity.
Well, the velocity is a vector, so speed is its amplitude. So if you want to use notation, that is a speed. That is a speed. That's called speed. How do we find the amplitude? That's right. Root x squared plus y vx squared. Again, can we use R? Give it a trial. Can we just use R? Can we just denote R equal to this number? Yes. Oh, no IJ now. No IJ now.
No.
No IJ now. It's just components. You have to use a square. Can you see? Just use a square. Do you know what I mean? So velocity amplitude is equal to x component velocity square plus vy component and the root in here. If it's a 3D, you can edit another one. If that is a 3D space, you can edit another one. You see?
Yeah.
Okay.
It says kilometers per hour.
Oh, you depend on the unit they're given first. Did you give it? What is the unit they provide in the first place?
Velocity, time is hours, and displacement is kilometers.
Oh yeah, automatically get that right. Yeah. So you just added a unit at the end. That's all. Before you go, do you want to try this one? How do we work out this one? So this is so you have to. How can we work out this one? Oh, I think this is not as simple as that. Do you remember? The velocity is equal to, there's a constant here, all right? You got, because R, can you see this when R is equal to R cosine, they have constant here, can you see? AT plus B, can you see? So when you do the first derivative, go to find the velocity, and these be careful, there are others. They must have the R multiply A, can you see? Sine AT. Okay, don't forget about this one. Of course, they have others. I will just remind you, right? This A, it must, don't forget about this A here, because you didn't write A here, can you see? You know what I mean? Oh, this is R, sorry, this is R. Oh, this, you should, oh, you know what I mean? You have to put the constant here. The constant, I just highlighted this constant here. This is pi multiple, is constant, can you see? Okay, yeah. So that's the only thing I can pick up. So other are correct, can you see? So A is equal to 1.3 pi, okay?
Yeah.
Don't forget. Okay, next question.
Find the equation.
Find the equation, yes. Find the equation of the path followed
by the object.
Yeah. Space station. Cartesian.
Sorry, by the object.
Yeah. So you need to find the path equation. Okay. The path equation is a time dependent, right? In the Cartesian, oh, okay, you have to write it in the Cartesian. You have to use X and Y. Is this a two-dimension? Yeah, it's two-dimensional, right?
Yeah.
It's a circular motion. Oh, yes. We have done that. We did it at the beginning. Do you remember? Here, it is a circle. Can you see? I did this first. Can you see? So you can use this one. You can find the path now. Try. Can you write it? Can you write the equation? So basically, can you give in this is R T is equal to the amplitude, right? The amplitude, I just amplitude. Cos a sine is sine or cosine? Is sine. First is sine.
It's sine.
The sine. That is oh, it's very strange number here. 1.3, right? And plus a constant, I don't know, doesn't matter. Okay, that is I, can you see? And another one is a cosine, right? Cosine, and this one J. Okay, from here, how can we work out the Cartesian? How can we translate that into the XY relation? So what is a Y? Can you, basically, I'm looking for this function, okay? How can we do that? That's right. Yeah. It's simple. So you just, it's called the parametric function, T, right? T is a parameter. So you want to get rid of T, what you can do? You can find the, can we say you can find X squared plus Y squared. Okay. So in this way, we can get rid of this sine and cosine. Can you follow me? R squared is equal to this one. Can you see? Do you agree?
Yes.
So, oh, it's not easy. Oh, have fun. They have constant here, right?
Mm-hmm.
Oh, I do a transformation. Can you see? I just use another y. Y is without this one. Okay, the y is just this term. Can you see? Can we call this just y dash? So we just solve this equation and do the translation. All right. Otherwise, the equation is too complicated for you. Can you follow me?
Mm-hmm.
I use a new coordinate in which this circle is the center at this position. After that, I just do translation. Can you see?
Yeah.
We put it downward. Okay, it's a circle, no doubt. It's a circle because cosine square theta plus sine square theta equal to unity. You agree?
Mm-hmm.
You can get you can in this way you can eliminate the t. Okay, this theta is equal to this strange number. You can see pi and 1.3. Okay, do you understand?
Mm-hmm.
So, done it. All right, let's stop here now. Let's let's see you next time. All right.
Mm-hmm.
Stop here.
Okay. Thank you.
Goodbye. Mhm.
Bye.